Okay, we're continuing in chapter 7, and on page 253 or 259, 7-3 rational operations. We're going to skip 7-3. It's yeah, we're just going to skip it. We're going to skip 7-4. It's talking about finding decimals for real numbers and such. And again, it's related to the idea that we don't have tools to enable us to do that. So we're going to skip over 7-4, and I want to take you to 7-5, in which we're working with radicals and we're dealing with properties of radicals. Okay, so we're jumping to 7-5. So this is page 264 or page 258. Okay, and so I really just want to kind of list these properties. We're not going to worry about the proofs. We just want to be able to use these properties. Okay. So there's the product property. And it says this: if we have the nth root of a times the sorry, I guess I can't read, times the nth root of b, and notice I just wrote them next to each other to represent multiplication, that equals the nth root of a times b. Okay, so this is the product property, and it works both ways. If I've got the nth root of a times b, I can divide that into the nth root of a times the nth root of b. Okay, so it's the product property. Right? If you look at the top of the next page, 259 or 265, you will see number 1 there. What is that? The fourth root of 8 times the fourth root of 2. Well, that would equal the fourth root of 8 times 2, or we could even say the fourth root of 16. Okay? So that's the product property. Okay, now the next theorem on page 258 or 264, I don't know that it has any name to it, but it tells us this, that if we have the nth root of b to the mth power, we can turn that into the nth root and take that exponent outside parentheses like this. Okay, and that can be helpful. Look at the very bottom of that page. If we have the, and I'll write it on the screen as I say it as well, the fourth root of 16 to the third, okay, well, if I just try to deal with that as it is and do 16 times 16 times 16, okay, that's gotten really big, and I don't want to have to deal with that, right? But if I realize, oh, I've got this property here, so I can turn this into the fourth root of 16 to the third. Well, what's the fourth root of 16? Well, that's 2, and so this is as simple as 2 cubed, which is just 8. Okay? And, that would work both ways. If I started here, I could turn it into that. I'm not sure why I would do that or under what circumstances that would work, but it's possible to do it either direction, okay? Typically, this will be something we're moving in this direction doing, and you can see how much simpler it makes this expression to simplify. All right? Okay, so then on the next page, this would be 259 or 265, there is the quotient property. And of course, that relates to division, and division is just backwards multiplication, right? So the quotient property, which is going to be a similar idea. If I have the nth root of a over b, that equals the nth root of a, the nth root of b. And since division is really just backwards multiplication, all this means is that if we have the nth root of two factors, we can separate those factors under their own radical sign. All right, and so you can see an example. Page 265, 259 of that. And that's really the bulk of 7-5. So for an assignment here on 7-5, I would like you in the written exercises to do numbers 2 through 14 even. And you're welcome to use a calculator on those. It says, the instructions you'll see use tables 3 and 4, but there's no reason for us to use there's no reason for us to use tables. You can just use your calculator to calculate those values and give your answers to 3 significant figures, if you can realize what that means, right? 3 significant figures. Now, starting with number 15, and I guess we'll actually say, I guess numbers 16 through, let's see, that's like 7 problems. 1, 2, 3, 4. So I'm trying not to overdo it. Yeah, 16 through 42 even. Okay, so here we don't want to use a calculator. Okay, so let's look at number 16 as an example, and we're going to try to not use our calculator. So we have the 4th root of 81 over 8. And essentially we want to simplify this. The instructions say to express each of the following in simple radical form. Since it says simple radical form, we can expect that there's going to be a radical involved in the expression where our solution. Okay, so we want to make use of the rules that we know. First thing is, go ahead and separate this into its parts like this. The 4th root of 81 turns out to be 3. We can check it on our calculator if we're not sure. I can do 81 y root of x and put a 4 equals 3. Okay. Now the 4th root of 8, I have no idea what that is. 2 is not the 4th root of 8. 2 times 4 is 8. 2 times 2 times 2 times 2 would be a 4th root, right? 4th root means using a number as a factor 4 times. And I can't think of an integer, at least, that uses a factor 4 times equals 8, right? So I need to do something different here. Well, hopefully you remember this from Algebra 1. A radical like this, I can turn this into an exponent, 8 to the 1/4. Okay? And so to get rid of the radical in the basement, okay, 8 to the 1/4 would have to be multiplied by 8 to the 3/4. It's called the conjugate, okay? In this case, it's the number raised to the power that when I multiply it together, it'll equal the power will equal 1, right? Because what's going to happen here is this is going to become 8 to the 1/4 plus 3/4. And 1/4 plus 3/4 is 1, so that the denominator is just going to be 8. It's not going to be a radical anymore. This is a way to get the radical out of the basement. Okay? But I have to multiply the whole fraction by 8 to the 3/4 over 8 to the 3/4. Okay? So now what I have is on top 3 times 8 to the 3/4 over over 8, because 8 to the 1/4 times 8 to the 3/4 is just 8. Okay, so now what can I do? Well, 8 to the 3/4, what I can do is I can turn that into 2 cubed to the 3/4 over 8, right? 2 cubed is 8, right? But we can multiply, so let's just think about this piece right here. We can multiply that and get 2 to the 9/4, right? Right, so, well, let me do this. 3 times 2 to the 9/4 over 2 cubed. I'm going to change my 8 in the basement to 2 cubed. And you might think, well, why am I doing that? Well, let's think about what we have on top. 3 times 9/4 is really 2 1/4, right? So we have 2 times 2 times 2 to the 1/4, right? And then downstairs we'd have 2 times 2 times 2, right? 2 cubed. So those 2's would reduce to 1, those 2's would reduce to 1. So what do I have left? I have 3 times 2 to the 1/4 over 2. Well, 2 to the 1/4 is just another way to write the 4th root of 2 over 2. And that's the best I can do with it. Okay, so there was number 16, simplifying it to simple radical form. Okay. All right, so number 18 as another example. Let's do the first thing we know to do and divide our fraction like this. Okay. And I'm going to put the 20 on top. The 5th root of -1 is -1. And that's over the 5th root of 625. Okay. Hopefully you followed everything I did just there. I don't know what the 5th root of 625 is. So at this point, I'm going to turn this into, I'll put a negative out here. We'll put 20 here. over 625 to the 1/5, right? Why do I do that? Sorry, I don't want to put the equal sign there. So that I can multiply top and bottom by what's called the conjugate, 625 to the 4/5. Why 625 to the 4/5? Notice what that does on the bottom. 1/5 plus 4/5 is 1, so I have 625 downstairs. Upstairs I have that negative sign, I have 20, and that's multiplied to 625 to the 4/5. Okay. All right, so then I'm going to take that 625 and realize that it's really 5 to the 4th. And then to the 4/5, I still have that exponent upstairs, and I have 625 downstairs. Okay. 5 to the 4th to the 4/5 is 5 to the 16/5. Okay. Okay, so what do I do at this point? Well, upstairs, because it looks like I'm going to be dealing with 5s, that 20 can turn into a 4 times 5, right? 5 to the 16/5 is 5 to the 3 1/5. In other words, it's 3 5s and then a 5 to the 1/5, right? So this portion right here is 5 to the 16/5, or 5 to the 3 1/5, okay? Downstairs, the 625 is 5 times 5 times 5 times 5, 5 to the 4th, okay? So we can cancel, 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 or reduce to 1. So now what I have is -4 times 5 to the 1/5. But 5 to the 1/5 is just really the 5th root of 5. So -4 times the 5th root of 5. Okay, and so each one of these 16 through 42, and I guess they're going to get pretty complicated here. So maybe a Zoom session will be a time for us to continue to work through those if you need that. But you got to manipulate your fractions. Now, the two examples that I did where we were getting radicals out of the basement, right? It doesn't necessarily work like for number 20, right? For number 20, you're not going to be doing what we did here. Your strategy is going to be different. Well, how is my strategy going to be different? That's a really good question, right? We start with the square root of 242 y cubed, right? Well, I mean, I can think of it this way: the square root of 242 times the square root of y cubed. Okay. The y cubed is easy enough to deal with because that is the square root of y times y times y. So the square root, 2 of those inside the square root becomes 1y outside. So that's going to be y square root y. And now we just have to figure out this square root of 242. Okay. Well, that square root of 242 actually has something interesting in it to me that I recognize. You may not recognize this, but I know it's divisible by 2. Well, I guess first off, I'm assuming that there's no square root of 242. And there's not. Okay. But I do notice that it's divisible by 2. And when I divide it by 2, I get 2 times 121. Right? In other words, it's the square root of 2 times the square root of 121. And 121 is an interesting number because it reminds me of 11 times 11. And so what I really have is 11 square root 2, that's the 242, times y square root y, that's the y cubed. So 11y times the square root of 2y. Okay, so notice there we didn't do any of that changing it into a fractional exponent y because it wasn't a fraction, right? The fractional exponent thing might come back up when you get to number 26. All right, so your responsibility then is 2 through 14 even. You are just using your calculator and you're coming up with the decimal equivalents here. And then 16 through 42 even, you're manipulating each of those expressions to get a simple radical form. So expect there to be a radical sign in your answer. Don't let the radical sign be in the denominator of a fraction. Okay? Enjoy this assignment.